Okay, and go ahead and start here. Wait for a little bit. We will be recording this for anybody down the road. If people join, we'll let them in as they go, but I'd like to go ahead and get started today. I'd like to kind of call your attention to what we have on screen here. Has this ever happened at your plant? We're going to go through looking at helping predictive analytics help you with possible disasters. Now, we show you one here that's probably a little more severe and for the wind sites, but if you're at any other kind of a plant, be either dealing with pump motors, pumps and motors, all it's the same. You can have stuff that fails on you and it breaks up in a hurry. And with me today, I'm your host. I'm Evans Heacock. I'm the director of NERC compliance here at Certrec. And we were wanting to discuss with you guys today about how about modernizing your plant and cut costs through analytics and machine learning. And a lot of this is for digitization, and we'll discuss some of that later. But also, my background has been plant design engineering for a good number of years, and also doing NERC compliance now for about 10 years plus. And with me today, I have Greg Wolfe. He's going to be doing the primary presentation as I host here. Greg is responsible and has the vision for doing what we're going to talk about, which is the Fischer Block. He's been doing 25 years of experience in the power engineering world, energy management, predictive analytics, which is again a big part of what we're going to talk about today. Computer networking. He's started off with Texas Instruments here in Texas. Go figure. And then going to recently doing Fischer Block. So he's got a lot of vision. This product in my mind is really kind of exciting from a standpoint of what it can do for the folks that have had plants past, older plants, and also brand new plants. So I am really excited about this particular product, and that's why we're working together with Fischer to try to help us go forward from a digitization standpoint. And Greg has introduced to us a simplification and putting this information in there and how we can get this information easily. If you could like to go through the agenda here real quick. Mm-hmm. Again, we've already gone through introductions. We'll go through some of that. We'll talk about our challenges and then how Fischer Block and Certrec are working together with this. It's definitely a collaborative effort between us, and we'll talk about how that can help you guys down the road from how we're helping them and looking at all this information. Again, the big part of this is predictive analytics, and Greg will go through that. The challenges, uses, and how we can install these, how easily these are really installed in the site, and then use it for fault recording, predictive analytics, the AI, go through conclusion and question and answers at the end. So if you have any, please, I believe we have a chat feature that you can ask questions. So you can ask them ahead of time, but we'll get to the end and we'll go through those questions and answers at the very end. And kind of go through it. One of our, here at Certrec, what we're trying to do is multiple things. We have a large message in the mission for helping generators, not only for compliance, but we're also looking at to make sure that it becomes reliable. And when we get to reliability, that helps NERC, right? So the new North American Electric Reliability Corporation is making sure we have a reliable and secure system out there. And how we do that is going through SAP applications and using various technologies like Fischer Block to help us go to a digitization down the road. So a lot of folks have a manual way of gathering information. They may have some remote devices that they put in and install that they have to specifically for looking at failures. But in this case, this one can be installed pretty easily to help us gather information. They can help you folks at the plants, predict possible failures down the road. Of course, we do compliance like we talked about, and also cybersecurity. Those are other areas that Certrec is really working forward and trying to help with and make sure maintain a reliable electrical grid situation. And again, real quick, and if you'd like to say something real quick, Greg, on this, Fischer Block is who we're going to be working with. They have asset monitoring, a leading asset monitor. Again, I'm really excited about this particular product, of the ease of installation and what it can afford and how information can be given back to the plants. Like that, anything just real quick?
Yes. And I'm really I'm excited about the opportunity to discuss our platform and to be working with Certrec. And I think we have very complementary solutions and offerings. And so I look forward to running through the details of our technology and how we're helping industry improve their operations.
Okay. So, and a lot of you folks out there in the utilities, especially at plants, older plants, and depending if you're a nuclear plant or fossil, or even the newer ones that we have with a solar battery, wind, the big deal is to make sure that you always have availability. If you have availability, then you're going to be able to produce power when you need to and make money. So that becomes not only from a standpoint of getting power out to the grid, but making sure it's reliable. So we want to make sure we look at that as part of going on forward. Equipment health. If you can start predicting equipment health issues by signatures that would come out of Fischer Block, that is actually adds a huge bit that advanced knowledge, so that maintenance can be done. It can be done planned, because we all know that bottom line there is maintenance is costly, right? So looking at this information, getting this information in, and then feeding and getting it to the maintenance folks, looking at planning when to do it instead of having it, catastrophic failure of a pump motor, say, we saw the blade, at the very beginning, or some other piece of equipment. All this information comes out as a signature, electrical signature, which the Fischer Block can pick up. So having that information come into the site is a real big deal from a standpoint of reliability, availability, and efficiency, and try to reduce costs in the future too. And of course, a big part of that is to help with that visibility. May not have it right now. So what we're trying to do is provide some information here, go forward with looking at that visibility, getting it out there. Fairly easy, then very straightforward solution here. So if you have that and you have reduced staff, then all of that information then can start coming in and getting it to where you can get that information ahead of time, so you can get increase your restoration time, planned outages or non-planned outages. So for that, I'd like to go ahead and let you go turn it over here to Greg now.
Yeah, great. And the area of predictive analytics today, or traditional ways of looking at operations, typically involves looking at SCADA data, which is the monitoring of electrical signals, primarily in terms of how much power is being generated and delivered, and what the usage of that is. What we're focused on is high resolution, continuous monitoring and analysis of the electrical waveforms, so that we can then alert on the reliability of the signal, not just how much power is flowing, but what is the reliability? Is it on the verge of actually an unplanned outage? Are there power quality issues that are going on, or transitory events that are indicative of insulation breakdowns that could become catastrophic? And so our solution is very complementary to SCADA, and it's a kind of an advanced level of predictive analytics to avoid unplanned failures and improve reliability. And so, as Evans has indicated, we have a sensor layer that installs fairly easily. We're a bit different than a lot of predictive analytics software companies in that we have not just the predictive analytics software, but we've also got a hardware layer that provides the advanced data stream, high resolution data stream into our platform. And what you see there on the left, it's about the size of an iPhone, or a smartphone. It's about 1.5 inches thick, and it installs in plants and in substations in many different ways. There's each installation seems to have a different vintage of what type of protection relays are installed, what type of test switches or test blocks. Is there access to the back of the panel, or is it purely a front panel view of the equipment? And so we've, over the years, have developed a number of different connection brackets so that we are able to install our sensors without an outage, without adding new wiring in most cases, and then stream the high resolution data to our software that is then analyzing the waveforms on a continuous basis and looking for slight distortions in those waveforms and associating them back to the inner workings of the assets involved. Right here is a drivetrain of a wind turbine generator, very similar to a motor, although the current's flowing the opposite direction, we're still able to glean health conditions of the moving parts inside the asset to alert when things are beginning to get out of the norm. And so it's really a platform that provides visibility across a whole suite of assets at a given plant or enterprise. And interestingly, although we're looking at electrical signals, we're able to ascertain the health of many of the mechanical components as well as the electrical system components. And we've got some slides later on in this presentation that show some of the case studies whereby monitoring the electrical signals either emanating from the generator or being consumed by the motors, the rotating equipment, the sine waves are not perfect. They have distortions that are very consistent, and they can be associated with, as you can see here, gear problems, bearing issues, winding problems, transformer issues, relay integrity, and so forth. So this platform of looking at electrical signature analysis provides early indications of both mechanical and electrical issues within a plant. And here's an example here where we did an implementation at a substation on the grid, whereby we installed approximately 40 sensors, I think 38 smart blocks, as it says there, all doing continuous monitoring of the voltage and current, three-phase volts and current signals going out to the grid. They're all communicating with each other through the local network in the substation, such that if any one device triggers on an event of interest, it sends out a trigger signal to all the others. And so they all capture their respective three-phase volts and current bus and feeder circuits at the same time. And therefore, the sequence of events is well beyond what a typical SOE capture is. So not only do we get the breaker trip and the signal to the breaker, but we also capture the fault signature and how it propagates across the buses, the adjacent buses, and all respective feeders. So it's a much more encompassing SOE picture, and it helps primarily with nuisance trips, whereby there's many circuits on the grid that have a propensity to trip breakers, and they can become very difficult to understand why that breaker's tripping. Many times the relay engineer doesn't even have a waveform to look at. And when they do, sometimes that can be difficult to determine the cause. However, if you're able to see an SOE sequence of events analysis across many buses and feeders in a given plant, then you can know where it started and how it propagated. And so that's one implementation and use case for our technology. And this one here, this is a very important use case as well. So a very critical asset here is a motor and pump at a chemical plant. And our platform is doing 24/7 continuous monitoring of the current draw from the grid into that motor. And the distortions on that current signature are very consistent, and they provide an indication here. You can see those side bands on either side of the fundamental, and the spacing on plus or minus on that 60 hertz indicates what slip the motor has versus the grid, because the motor's running a little bit slower than the grid. But in this case, there was a overheating rotor bar, which eventually cracked. And that overheating rotor bar is typically from a problem with the rotor windings or stator windings even. But that distortion will show up in the electrical signal. And then when we're doing a continuous FFT frequency extraction on all the signatures that we capture. And you can see there the sidebands indicating a developing problem. And then they will schedule that. And we watch those sidebands grow over many weeks and months. So they can plan their maintenance without having to be reactive and be much more proactive and resolve issues before catastrophic failure. And so we've heard many of our customers say, wow, we have new visibility. You know, we've had sporadic visibility where we have waveforms on some circuits and not on others, SCADA data on some and not others. And with our system installing without an outage and with no wiring, they can get full visibility across a plant inside of a couple of days with very non-invasive installation, and then immediately start seeing what they have never seen before. It's interesting to see some of the engineers for the first time actually viewing waveforms from circuits that they've worked on for many years and decades and have never seen on a consistent basis, only when there's an event. Now they can see, wow, it's leading up to an event, or I never realized there was so much distortion on these lines as I'm seeing now. So it's an exciting time, I think, for the industry. We commonly get asked, you know, how do we specifically pick up volts and current without any wiring? Well, here's an example of, on the left is the back of a panel. And when we install our device, which we call a smart block, on the front of the panel, we will then typically use a hollowed out bolt, what we call a smart bolt, that we mount on the panel, and it's underneath our device. And we then run an insulated tube right to the back of the panel, and we snap on a three-phase split core CT probe assembly. And those are hinged. They're not shown in the picture, but they hinge open and they just snap around the secondary wiring so that there's no new wiring and there's no disruption to the existing wiring as we make that connection. And then sometimes we'll actually, if there's access to the back of the panel, some of the panels in substations on the grid and within plants, you can walk to the back of the panel as easy as the front. And so we can install our device right to the back of the panel. In this case, it's to the back of a flexi style test switch. We have ruggedized push pins underneath, picking up three-phase voltage. And then again, we'll snap on a three-phase split core CT assembly right there next to our device.
So let me ask you a quick question. So this can tie to a flexi test on the back side or the front side of the panel?
That's right. When we connect to the front side, it actually acts as a retrofit cover. And it replaces the existing cover on a flexi test switch just with 2 thumb screws. So it's the same attachment and removal as a normal test switch cover on the front. And then on the back, we just have a special bracket that takes advantage of the existing bolts on either side of the test switch. And so it's a situation where you don't need any additional real estate on the panel, and it's just a 5-minute install in that case.
And then for communications, you do a wireless. It can be wired or wireless, typically. Typically, most.
That's right. We typically will do twisted pair copper Ethernet cable, although we do have implementations where we use fiber as well as Wi-Fi.
Okay, so yeah, that makes it very quick and easy to get the signals once you install it, which is one of the things that, like I was telling y'all at the beginning, this is exciting because of the ease of installation and the information you can get out of it. This right here is probably the biggest thing, especially for some of the older sites where, you know, you might be worried about trying to do the installs on these.
Right. We've installed our system on panels that are 1930s, 1940s vintage, asbestos even, where they don't want to mess up anything much. Just a very quick install without disrupting operations. And even some of the rail substations in the Northeast here in the 1940s vintage, all the way up to modern, you know, brand new substations.
Yeah, especially with the split CT, you know, that makes it very easy to get into the existing current circuits too. So, you know,
that's right. And these are revenue grade CTs. So it's They are split core, but technology of CTs now has advanced. So we're able to pick up very, 100 dB, 90 dB dynamic range. So we're monitoring the full three-phase volts and current, but we can also see just, infinitesimal changes, minute changes in those signals, and track those over time as well.
Okay, thank you.
And so here's an example, just kind of a listing of some of our customers that are using this technology in the wind applications, solar applications, even fossil fuel generation plants, manufacturing, as well as transmission and distribution grid delivery applications. And this is what I'm really excited about in terms of our edge devices. We typically stream into Wave IQ, which is our software. We do have a third party where we stream into SCADA systems. However, providing the API into the Certrec portal then provides the ability for the Certrec customers to gain access to this predictive analytics and the insights through one common portal, being the Certrec portal.
Yeah, and that's where part of our partnership comes, and our Certrec portal, when we talk about that, is actually it's a protected system. We have our servers are FedRAMP. For those that may not know that, but that's basically all information stays within the U.S. and it's secured. We do transmission of information that's encrypted while in transit and while at rest. So our Certrec portal is a very secure system, and it's gone through many checks. Part of it is we have an ISO program to make sure that we meet the 27001 requirements for insurance of that information out there. And then we also have what we call a SOC 2 type 2 examination. This looks at, make sure that we follow our processes, that we have them in place, and we're examined every year. We have not had any, Certrec has not had any issues and findings during those audits. So that all the information ends up being stored securely, and then at which time then we can get in touch with folks that would want this kind of service. We can help them with that information, help them with analytics, as well as Fischer Block. And as far as some of the items that we have, when we talked about it from the beginning, not only can this help with analytics for looking at the equipment, it actually does get into some of the NERC that can help us with the NERC information. There is sites that are required to meet the PRC2 disturbance monitoring recording requirements by NERC. These would actually install very easily for that purpose, from the sequence of events type item or a fault recording, and also what they call dynamic disturbance monitoring. This product has and records the information at the rates and store the pre-fault, pre-event situation all the way through the amount of time that it has. Of course, this information is pretty much continuously recorded, and then all that would come into our system once it was realized that there's an event, you need to look at it. It can also help from a standpoint with the VAR2, which is generator operation and maintenance network voltage scheduling. If a site does not have real good ways of monitoring this information, this also works pretty well to make sure that not only can they say, yeah, we have what we need, but it also, if you haven't had recording capability, this can also do recording to show that they stay within their voltage requirements that are set out by the transmission provider. Typically, they'll make sure. So this can help from a NERC standpoint also. So going back through, one of the conclusions that we're looking at here is really it does help your return on investment. It's really very low cost for a lot of folks. So especially if you start seeing it and you're monitoring your equipment, there are a lot of sites out there. I know over the years that I've dealt with them, we're looking for analytics, to help us with make sure we're doing maintenance when we need to, looking at motor issues, looking at the equipment issues from a standpoint of pumps, again, the electronics. All this will give off some sort of a signature, so you can see that ahead of time. So it does help with, has a very good return on investment. It looks at reliability and visibility, like Greg's talked about. They can see it from their analytics, pulls it out. You can see it, and it'll bring it to your attention. And then also helps with the compliance from a NERC from a standpoint, but also reduces risk at the same time. again, risk from looking at your equipment, making sure you can take something out once you start seeing a problem. His example was looking at a rotobar. You start seeing that information across, you can say, okay, we need to take an outage, and then you can do that smart instead of waiting for it to fail, and then you're really in trouble, kind of thing. So for our next steps is like, how can we help you, utilize predictive analytics? You get with us, we can talk to you about it. And then also, what key areas are you hoping to improve? Get back with us, we can talk about it. And, here in a little bit, we'll have some question and answers. If anybody has questions and answers out there, we'll go through that here in the next. But I know we'll have a tie to being able to get back with us through Certrec to, schedule something going forward to help you with you in the future. Anything else, Greg, right quick before we go to questions?
No, I mean, one of the things I would say is, on the return on investment, we've got what we call a Smart Start program, which is an evaluation program that will actually demonstrate the ability to see pre-fault indicators. And we've had numerous customers tell us that the platform has paid for itself inside of 1 year based on either quicker restoration times or preventing unplanned outages.
Okay. All right, I guess with that, we can go to questions, and we'll have our general moderator over there. Do we have some questions, Brandon?
Yeah, we have 2 questions in the chat. The first one says, I imagine there is a remote monitoring capability. What cyber vulnerabilities does this create, and how are they mitigated?
Okay, so from cyber, I'll let Greg start, and then I'll add on to that.
Right. So, and a typical implementation of our smart blocks and Wave IQ is such that the server that communicates with our devices resides on our customer's premise behind their firewall. And many times it's not on their network, although if it is, it's underneath and maintained within their cyber guidelines. And then in this case, in terms of the API link to the Certrec portal, I'll let Evans speak to that.
Okay. Yeah. So part of that is that once you get behind the firewalls and you have data, the data information would be transferred through the firewall. You would have that information go, and then once it gets to our servers, and then, like I said earlier, we have encryption on our system. We have a Fed, our facilities for our servers and are FedRAMP qualified, which is federally reviewed and said that yes, all this data will stay within the U.S. so we don't have any information in it. And again, primarily the information we're looking at is data. It's not a control system; it's a data system. So from a standpoint of controls and data, those two would be separated. So it would not have essentially would not have that same vulnerability back into the system through the acquisition of this data, but it's also through a firewall. So it's protected all the way.
Yeah, Evans, I'll make one more point. We've taken great care to make sure our devices do not have any digital outputs. There's no outputs on our devices, such that there's no ability to control any other equipment. And it's purely then just a data monitoring, what are the signals? And so there's no ability, it reduces cyber complexity and risk significantly.
From a cyber threat standpoint, yeah. Since it's just gathering data, it's not controls, and it does not have any way of injecting any kind of signal back that would be a controlling or shorting type situation for the circuits it's monitoring.
Mm-hmm. Yeah.
Okay.
All right. Here's another question. Have you had any pushback on wireless for those who don't want a vulnerable network access, such as wireless?
Yeah, as I kind of mentioned earlier, our primary implementation is twisted pair copper. We have very few wireless implementations, and where we do have them, they're primarily have been in a commercial environment. But it's what the customer's IT department typically recommends. Our platform's flexible to handle multiple communication options, including DNP3.
All right. Here's another question. Can you provide examples of how nuclear power plants have utilized this technology? Does it have any utilization for nuclear plants?
Let me start off, and then I'll let Greg,
Go ahead.
since I have a background in nuclear. So what I will say is that from we have safety and non-safety features of nuclear plants. This would not necessarily be at this time something that's going to safety, but you could do it on the non-safety for all the balance of plant type circuits out there. And you could, and then it goes, as you saw on one of the pictures, that we had through here, Greg showed those installs on the front of the switchgear. You could actually easily put this on the front of the switchgear, non-safety switchgear, and have those CTs go into the, with the split CTs very easily from a nuclear power plant standpoint. That's really why I'm really excited about this, because it is so easy. You could go into new plants, not necessarily safety related. He has not done any of the qualifications for that at this time. It doesn't mean it couldn't, but just right now it's be a non-safety function. Great.
Yeah, we're in generation plants with a number of utility partners, and we've just recently been introduced to their nuclear groups. So we're hoping to have some implementation soon, but to date, we've not actually physically installed our devices in a nuclear plant.
Again, doesn't mean they can't be. It would be right now non-safety application, which is a major portion usually of the power system at a plant.
Mm-hmm. All right. Another question. Is the store on the Certrec server? If the answer is yes, then how does the station have access to analyzing the data?
Did they correct that? Did I see a correction from George on that question?
Let's see.
Data. So the data stored, yes. The data would be stored on the Certrec servers. And I messed the rest of that question now. What was the second part?
If the answer is yes, then how does the station have access to analyzing the data?
Well, with that, we ended up having to set up an agreement with the station. Either we could, we would probably do a lot of the review from a Certrec standpoint, and also, Greg's team, look for what's going on, from the information as it comes through the analytics. And then we would actually allow whatever station access to information as it comes across. We can send it to you. We would set up an access for you, for the site to access it. A lot of plants out there right now have access to our portal, our Certrec portal, for various reasons, and this would be just another item that we could turn on if they already have access. Again, a lot of the nuclear plants do have access to our servers, and this would be just another feature that we would turn on for them to have access to.
All right, I've got one more question since we're getting close to 40 minutes. How does your platform learn?
Great. It's a good question. Pre-fault indicators are one of the primary focuses of our platform. Protection relays that are in plants and on the grid, they're primarily capturing waveforms when a breaker trips. What we're focused on is providing early indicators before a breaker ever trips in order to avoid that unplanned shutdown. And so we're doing 24/7 continuous monitoring at the edge within our smart block devices. And those devices, when they detect a condition of interest, which is exceeding a threshold that the WaveIQ software platform has programmed into them, they will then send that waveform up to the server, and then the server then performs the frequency extraction, the FFT, Fourier analysis, and breaks out all of the frequency components of those time series signals and tracks those over time, the magnitudes, the severity, and those distortions then have a norm to them. There's a historical norm that a given circuit or an asset will exhibit. And when things start getting out of the norm is when the alert notifications and greens go to yellow and eventually can turn to red on the dashboards. When there is a breaker trip, that is also then experienced and captured by our platform. And then our platform knows, okay, everything that was measured on that circuit leading up to the breaker trip, weeks and months leading up to it, is now information that can be used to learn and predict the next event on that or in a similar circuit. And so that's how our device or platform learns. It's from tracking out of the norm small events that lead up to breaker trips, and then that goes into the data set and the data lake to help reliability going forward.
All right, we got another question from Bill. Can your analytic data be exported to a PI server?
PI server? Yeah, well, maybe you should answer that first, Evans, in terms of our data residing in your portal.
Well, I would say yes. If anybody, and then part of this is all agreements, we can set up the information transfers however we need to in the end. So if it needs to be sent back and that's the way it's preferred, then we'll work with the customer to handle that. So we can send it back to the clients, because yes, especially with PI servers, I know how, especially a lot of the system engineers at plants, or engineers that are working on maintenance and whatnot, they're going to be interested in that particular bit of information. So yeah, we can. It would be done with an API, kind of like what Greg was talking about earlier. Send the information to the Certrec servers.
Mm-hmm.
I would also add though too, depending on firewalls too at the sites, depending on what they have, trying to get that back into to a PI server of some sort, may be a little bit complicated, but it really depends on firewalls again, and firewall rules, what's allowed.
All right. Here's another question. How many edge devices can be supported by Wave IQ?
That's a real good question as well. And the benefit of having the intelligence at the edge within each smart block is such that the smart blocks are not inundating the servers with continuous waveform data. It's only when the smart blocks detect a out of the norm condition, and there's a circular buffer within each one. So each one's able to go back in time several seconds and then capture the event of interest, as well as going forward, and then sending that data set to the server on an exception type basis, so that the burden on the communication network is extremely low. And so we've got some implementations where it's in excess of 1,000 devices streaming and supported by one implementation of Wave IQ. But I will say though, the Wave IQs are modular, so that each Wave IQ instance can then be accessed and have API hooks into other Wave IQ instances throughout the enterprise.
And what is the data format for Wave IQ inputs and outputs?
We've got multiple different formatting options. We have a native protocol into Wave IQ from our devices data format. However, from Wave IQ out, we have ComTrade format, industry format, PQDiff, DMP3, Modbus. There's several different protocols. And then out of the Certrec portal, I'll let Evan speak to that.
But again, it'd probably be whatever we need in the end, with client. There's lots of ways of handling this information. So really, we will work with whoever we need to, from pretty much any kind of situation. Anything else, Brandon?
I'm not seeing any more questions in the chat, so I'll ask one more question for myself. Where does the data reside?
So it initially will reside, through their pickup, and then the information is transferred, and the data is will finally reside on the Certrec portal, the FedRAMP secured facility, data facility. Certrec does use FedRAMP facilities that are primarily located in the Virginia area at this time.
All right, I think that's about it for Q&A.
Mm-hmm.
Okay, and again, like to appreciate all the questions we got, and thank y'all for joining. here's a link, that you can get to. I don't think you can do it clicking on your screen here, but if you would, you can visit write down the address there that he has. I think we can get it through the Certrec portal also. Can they get to it, Brandon?
It's a sign up page on our website. It's not on the portal.
That's on the website. Okay, on our
Yeah,
website.
yeah.
I just go to our website.
It's Certrec/reliable power.
Okay, so you can go there also. And if you need to get back in touch with us, but we do appreciate y'all joining us today and the questions.
Great. Thank you, Evans. I appreciate it, and appreciate everyone's interest and time as well.
Thank you for joining us today. Great. A lot of good information there.
My pleasure. Thank